find the normal line and the tangent plane to this surface. I want you to find the equations of the normal line and the tangent plane, that is. Alright, so I want you to pause the video, write this down, and make an attempt at it. Okay, you finished? Let us look at this particular question. Now, you remember that the general equation for the tangent plane is in this case, you have f of x, y, z. So the derivative of f. Let's first see how we can write it in another form and then convert it to that general form. You remember the general equation, the derivative of f with respect to x times that small change in x plus the derivative of f with respect to y times a small change in y plus the derivative of f with respect to z times a small change in z. Alright? You would have said this is equal to f. But in this case it's going to be equal to 0. Remember where this comes from? You have your x, y, and z axes, and then let's say you have some points somewhere up here. You have to move, well, you did, first of all, let's rewrite this small change in x as what it should be in the general case. I'm just looking at ways for you to remember this formula, just in case you get it in an exam and you don't get a formula sheet with it. This change in x is the general x minus the x at a specific point, a stated point 0, which we'll call ground 0. That point also has a y. You have a general y minus the location of y0, then the general z minus the location of z0 or z0. Some people say z0. Alright, so this is the point located at x0, y0, z or z0. In order to go to that point, you have a general point anywhere in this line or on this surface. This is the surface that we have there. Let us draw some lines to show that it is a surface. Alright? And then you move towards the point and you move in that direction. Let me do that again. So you move towards the point from y, line up so that you will get from x, line up so that you will get towards that point. So you go to x0 along the y, so you move a bit closer. You change y from y to below y0, and then you go up to touch the point at z0. You could replace this by one straight vector, that vector there, but that vector is the vertical and horizontal components would be the change in x, change in y, and change in z. The change in x would be x minus x0, the change in y, y minus y0, the change in z, z minus z0. Alright? So you see here, why is it equal to 0 again? Because if you consider a vertical a normal vector orthogonal to the plane, 90 degrees to any vector to this plane, the cross product between this normal vector and any vector on the plane would be 0, right? Because they are at 90 degrees. So it would be like you have this normal vector n equal to a, b, c, and it's a vector. Alright? The dot product between that and the change x minus x naught y minus y naught z minus z naught. The dot product between these two vectors would be a times x minus x naught, b times y minus y naught, c times z minus z naught. But instead of a, b, c, you're looking at the gradients. Alright? So we have delta z by delta f by delta x, delta f by delta y, delta f by delta z. And it lines up with the equation we know already. Delta, the change in the partial derivative of h with respect to x times a small change in x, and so on. Alright? So try to remember this formula, just in case you have to work it out in an exam and no formula sheet is given with it. Alright, so we have that formula there for the tangent plane. We're going to need to find these derivatives, right? Now, the gradient represented by the upside down triangle, the gradient of a vector f, is going to be delta f by delta x plus delta f by delta y. Oh, not plus. It's not plus, it's comma. Let's see if I can find it. Alright. These are the three components, and then you have z delta f by delta z, the three components there. Alright. Now, here, we need to find out what these things are. Let's work it out here. Delta f by delta x is equal to what now? Let's see if we can differentiate this thing. You have 3z squared, that will go to 0 because we're treating z as if it's a constant. 4x squared y will be 2 times 4, which is 8, x to the 1, y. So it's 8xy. This will be 8xy plus, then what will happen here now? X is raised to the power of 1. So when we say minus xy squared, we differentiate this partial with respect to x, we're going to get negative y squared. So this will be plus negative y squared. Alright? What will happen here? Look at this. This will be 2 times x, then y squared, z squared. So it's plus 2x, y squared, z squared. Alright? That's the partial derivative of h with respect to x. What about the partial of f with respect to y? Sometimes person would say the partial of instead of saying the partial derivatives of. Leaving out the derivative, it saves some effort and time and energy, I guess. But anyway, partial derivative of f with respect to y. We're treating x and z as constants now and y as the variable. So this part that becomes 0, the derivative of a constant. This part now, y. We'll have 4x squared if you remember your differentiation, which you should, for x squared. Then what happened here? We differentiate with respect to y, so this will be minus 2xy. Alright? So we have minus 2xy, and then what will happen here? 2 plus 2, it will be plus 2 x squared y z squared. So it is plus 2 x squared y z squared. Good. Then the partial derivative of f with respect to z is going to be, no, this will be 3 3's 9, 9z squared. Alright, so we have 9z squared plus, and what will happen after? This will be 0 because we're treating x and y as constants for now. Same thing will happen here. The xy squared that go to 0. Then here now will be 2 x squared y squared z. So we have 2 x squared y squared z. So we have our 3 partial derivative there. Alright? So now we know that these are. Now the x naught, y naught, z naught, what are they? Well, x naught equal, y naught equal, z naught equal. They will be the coordinates that we have gotten. 2, negative 1 and 3. Alright, that's ground 0 there. 2, negative 1, 3. Alright. So we can now write our our equation for the tangent plane. But just before we write it, remember, we also ask for the normal line. Remember the formula for the normal line? If you first remember, first of all, you will write it in parametric form. You will introduce a third variable. T is a popular one. Alright, so let's use T. Now, you remember that the general equation for a straight line is y is equal to mx plus c. But what is m? M is the gradient. The gradient, we can use a gradient function. So here it's partial derivative of something. So it's going to be, in this case, x equal, then we're going to have y equal, and then z equal. Alright? X equals going to be delta f by delta x, that's the gradient, times the new variable t plus that constant. Now remember from maths before, you remember that the gradient is the rise over run. Alright, and then the c is the y-intercept. That's a certain point on the y-axis. Now that's a constant as well as the gradient. That's going to be a constant for a straight line. For a curve, it keeps changing. But what will be the constant in this case? Well, we know one particular point that we're dealing with, and that is x naught. Alright? Similarly, y is going to be delta f by delta y times t plus y naught, and z is delta f by delta z times t plus z naught. So these are the normal line parametric equations. Alright, parametric equations for the normal line. So now we have our values. So let's see how we do it. For the tangent plane now, let's look at it. The equation for the tangent plane is delta f by delta x, x minus 0. But in this case, our delta f by delta x will be at this particular point. We didn't calculate that before. We need to calculate exactly what the delta f by delta x will be at this point, right? So delta f by delta x at 2, -1, 3 will be equal to, in this case, 8xy, 8 times x naught is 2 times y naught is -1. See that? Minus y squared. So it will be minus -1 squared plus 2xy squared z squared. 2xy squared z squared. And it will be 2 times x naught is 2 times y squared is -1 squared times z squared is 3 squared. Alright? Now, what does this work out to be? A2 16, -16, right? Equal -16 minus 1 plus 2 2's 4, 4 9's 36. So let me just work it out on my calculator here. -16 minus 1 plus 36 gives you 19. Alright? 19. Good. What about delta f by delta y at that point? Delta f by delta y at 2, -1, 3 is equal to, now we look at our formula, 4x squared minus 2xy. So we have 4x squared minus 2xy plus 2x squared y z squared plus 2x squared y z squared. Now let's put in the values. X is 2. So it's going to be 2 2's, 2 squared, 4 by 2 squared minus 2xy. X is 2, y is -1. So it's 2 times 2 times -1 plus 2x squared. X is 2, so it's 2 times 2 squared times y. What is y again? Y is -1 times -1 times z squared. ZO is 3, so it's times 3 squared. Now what will that give you? Let's see. 2 2's 4, 4 4, 16. So we have a 16 here. A minus negative, so we'll have a plus. 2 2's 4 plus. We have, let's work this out. 2 2's 4, 4 2's 8. 8 times 9, 8 9, 72. So we have 72, but this will be a minus. So it's plus negative 72. So we have 16 plus 4 minus 72. That gives us what? Negative 52. Alright, negative 52. And then after that, we have our delta f by delta z. Delta f by delta z is equal to 9z squared plus 2x squared y squared z. So it's 9z squared plus 2x squared y squared z. Now z is 3. So 3 squared. So it's 9 by 3 squared. 2 times x squared. Let's give some space here. X, what was x again? X was 2. So it's 2 squared. So it's 2 by 2 squared times y squared. Y was 3. So this is 3 squared times z. No, y is negative 1 and z is 3. Oh, my mistake there. This is negative 1 squared times z, which is 3. Alright. 3 3 is 9. 9 9 is 81. So this will be 81 plus 2 2 is 4. 4 2 is 8. 8 3 is 24. So 81. That will be 81 plus 24. And that gives us 105. Alright, so we have all the values we want. So we fill them in now. Let's look at the tangent plane first, since that was what we wrote down in the first place. The tangent plane. That tangent plane, it is, let's repeat the formula for it. Yeah, let's write it under here. Delta f by delta x, x minus x naught, plus delta f by delta y, y minus y naught, plus delta f by delta z, z minus z naught equals 0. Alright? And it's good to write it down each time, so it becomes a habit, so you will remember that formula. Now everything, oh my, it jumps all the way up here. Alright, we're back. Everything here happens at what I had called ground 0. This point, 2, negative 1, 3. So delta f by delta x, it was 19. So we have 19 x minus x naught. We'll put in the x naught, change it later on, plus delta f by delta y was negative 52. So this would really be a minus. So we say minus 52 y minus y naught plus delta f by delta z is, what was it? Oh, 105, right. 105. So here we have 105 z minus z naught equals 0. Now, what were these x naught, y naught, and z naught business again? 2, negative 1, and 3. Alright? So, this is 2, this is negative 1, or when you say minus negative 1 is same as plus 1. This here is 3, so we say minus 3. Good. And of course, you could multiply out the brackets and so on and so forth and simplify it. Now, as for our normal lines, this will be delta f by delta x. It was 19. So, this is 19t plus 2, if my memory serves me right. This one was negative 52, right? Negative 52. So delta f by delta y is negative 52t plus, and then the point is at 2, negative 1, 3. So here, y naught is negative 1, so this will be really a minus 1. And then delta f by delta z was 105, so it's 105t minus, and that third point was 3. That third coordinate was 3. Alright, so here we have the three parametric equations for the normal line, right? We also have the equation for the tangent plane to the curve.